this is Arnoud, WizBiz.com, and from one of my earlier videos here on YouTube, you might remember my effort to develop a Arduino microcontroller that's compatible both in form and electronically with the vintage electronic Fischer Technique modules called Silberlingen. The original Fischer Technique rectifier module could be used with these 3D printed remakes because the power supply is looped through metal strips on the sides of the module that can be connected by means of small strips. And although it's usually sufficient to use the original 9 volts that come in this way, it would also be very nice to connect an optional external power supply over here on the back of the little box. For instance, if you have to power pneumatic valves, lamps or motors. And the 9 volts from the sides over here, if that could be automatically overruled by this external power, that would even be better. And furthermore, this PCB should take care of producing 5 volts for the Arduino, 9 volts to be compatible with the original outputs of the Silberlingen, and it could make the programming port of the Arduino and the I2C bus available on the back as well. So we've got a lot to do. It seems high time to be developing a printed circuit board again. Unfortunately, the last time I did this was over 30 years ago. And after a little search on the attic, I found some ancient designs. These are some designs I did in Protel. I drew the schematic and did the PCB copper routing with that. Must be somewhere in the 80s until the mid-90s of the last era. Protel doesn't exist anymore. It's now called LTM Designer or something like that. But the main thing in these days was that the lines did not let any light through and you had to do it in mirror image. Wow, here's one from 1983. And these light-tight lithographs made it easier to make double-sided print designs. A piece of photosensitive print material was then sandwiched between the two designs during the exposure. And doing this exposure was something really special in these days. I once made this light box myself. Completely deteriorated foam after 35 years. An on-off switch and a timer switch, and you could place the design with the print material under this cover. More deteriorated foam. It even is stuck to the glass plate. You can't see it, but below there are the UV fluorescent tubes that expose the photosensitive print material. Gee, this has not been used for a long time and I think I'm gonna recycle this thing. Which brings me to the most horrible part, the etching. I found my etching bin in the attic museum. And you could slide your print in here and then you just had to hope you haven't overexposed or developed too long and that your design has been light tight enough. Small thermometer, small aquarium pump was on it. And look, a complete bottle of hydrogen peroxide. That seems to be enough to bleach my hair for the rest of my life. Well, away with that. Let's see how we could make our PCBs a lot easier nowadays. Alrighty, so let's take a quick look at the schematics that I have drawn in KiCad. I used 3 voltage regulators. One for the main microprocessor board. You have a TO22 footprint available on the PCB there, so you can you can either use a 7800 series voltage regulator that will provide you with only 1 amp, or you can put a 1.5 amp type in there. The CV series will give you that, or you can use a 7800S type, which goes up to even 2 amps. I call this VM. So this auto switched over those 2 power Schottky diodes, and if you don't connect the external power supply to the back of the case, then your normally Fischer Technique rectifier module will provide you with around 10 or 11 volts DC on the sides of the case. Here on the bottom, another small L-type voltage regulator that is especially been set up for the voltage of the I2C bus. So you can choose a 5 volt type if you'd like a 5 volt I2C bus, or a 3.3 volt if you should prefer that, or your sensors or other things that you want to connect demand that. Also on the PCB already the regular 4K7 pull-up resistors. So these connectors are on the back. These are the optional power supply. These represent the strips, the power strips on the sides of the casing. This is a connector inside the Zauberling, and this is another connector inside the Zauberling. So these two go through the main PCB, and these are also on the back. And this is a connector, your TTL interface to program your Arduino Pro Mini. So you can program it with a connector from the back of the Zauberling, and this I2C bus, of course, is also on the back of the Zauberling. Okay, so once we have set up this complete scheme, we can go to the PCB. There are a lot of great tutorials about KiCad online already, so I'm not making another one. If you would like to go the way that I did, you will find that there are really good information. There's really good information available. So this is about it. You already see, perhaps it's nice to mention that the edge cut, the special edge cut, was a bit of a problem to get in there with the right dimensions. After some fiddling around, I imported as a factor, as a bunch of factors, by the way, from Affinity Designer. So that was difficult, and then I placed all the components within this edge cut, of course, and I made the routing. So it ended up something like this. And yeah, a nice thing about KiCad is that it will also provide you. Let's see if I can give you that as well. It also provides, yeah, there it is. It also provides you with a nice 3D preview of your PCB, as you can see. That makes it possible to see any pitfalls or problems with placement of components or other things that might come up when you inspect it before you let the production go on. Okay, so this is well, in a nutshell, in a quick view of, about how I did it. So this is my PCB, and I printed some Gerber files from it and just sent them to a online PCB production facility. And then, after a few weeks of patience, the 10 PCBs I ordered arrived. And as you can see, all nicely packed. By the way, I took the opportunity to have all the SMD components soldered directly to the PCB after they were produced. And I was very curious to see how that worked out. The online service I used offered this assembly service, and all it took was creating an additional assembly list with a choice of the components they offered. These, of course, had to match the footprints I used on my PCB design. By the way, should this video be in any way useful or entertaining to you, please subscribe to my channel. Click the bell to get notified when I'm posting something new. And well, there they are, 10 beautiful professionally produced circuit boards. Didn't even cost me more to have them produced in black instead of green. It all looks quite beautiful and useful, and partly already assembled as far as SMD components are concerned. I only have to fix the connectors and the voltage regulator in the middle. As you can see, all the small voltage regulators, SMD types, are already soldered on. Saves me a lot of work, I guess. And I only have to fix the connectors and the big one in the middle. So if we solder on the connectors that come out of the back of the Zauberling, And finally the header strips that are used for transmission of the signals and the power voltages between the PCB and this power PCB. It can be built in a Zauberling housing, just like so. Here's one I already soldered the missing components on, and it fits in nicely. So for the future 3D prints of the housing, I'll probably make the openings directly in the STL file for the 3D printer, but for now the bottom silk screen in the Gerber file could be a good starting point. If we export that layer as curves and isolate them and clean them up in a vector drawing package, it's quite easy to extract the outlines of the correct cutouts from that. My choice will be Affinity Designer, but of course any vector app can be used to produce an SVG file that may be read into your 3D software. So here the curves of the holes are brought into Blender. Let me extrude these curves into solid objects so that can be used as Boolean objects to Boolean the holes out. Let me see if I selected the correct set of vertices here. Yeah, that's okay. Move that. No, not along the X, but the Z axis, like so. And to cut through the bottom, and then we can use it to Boolean cut the holes from the bottom of the 3D print file. I also printed a mirror image of this on paper, and for now I'll make the necessary holes by hand. So this might be a little trick you can use yourself when you're in this situation that you have to make holes on exact locations of a printed circuit board that's inside. Just print it in mirror image, stick it with non-permanent adhesive to the back of your object, and saw and file to perfection. There you have it. Yeah, let me assemble a few of these things and check if they're working. Seems that all the voltages are there. Just connect the external power supply to the back. It's 12 volts at this very moment. And well, there you have it. By the way, I used small aluminum 4mm spacers to mount it to the bottom, and that exactly leaves the connectors flush to the back side, so nothing is protruding. It's really flat, and you have all your necessary connectors on the back. Let's take a quick look at whether this power supply PCB is sufficient to supply a Zauberling main PCB with the different supply voltages. Here you have a sneak preview of my next version of the Zauberling on this test board, and you can already see there will be an OLED display on there. Zauberling itself draws less than 50 milliamps, the motor's 100 milliamps, but of course it becomes interesting when we put a little load on these small motors. But even then it stays somewhere between 150 and 200 milliamps. I don't think that's a problem in terms of heat buildup from the large voltage regulator. You can choose a 2 amp type there, but I've now opted for a CV type that can handle 1.5 amps. No, it really does not get very hot on these infrared images. It always seems there's been an awful lot of heat being generated, but it's not the case. Around 30 degrees is perfectly fine for these regulators, so it all behaves very nice and seems to be well dimensioned. No additional heat sinks or ventilation slots will be needed, I guess. Alrighty, so far so good. A neat professional print in a 3D printed box fits very nicely, neatly located on the bottom of the box, so the main PCB can be placed on top of it in the near future. On the back here we have the I2C and the programming interface. We have headers for giving all the voltages to the main PCB. Okay, this is to be continued, of course. I hope you liked it so far. If that's the case, don't hesitate to give it a thumbs up and subscribe to my channel. Happy hacking!